Go live on YouTube. We are live on Twitch. And joining me now is my colleague in crime, our aerospace correspondent, Eric Mattis. Eric, when you were getting your English degree and taking geology courses and playing far too much Kerbal Space, did you ever imagine you'd be reporting on rockets?
No, I never did.
Was it something that, like, as a small child, you might have considered cool to know that that's what adult you would be doing?
Yeah,
So you made baby you proud without even trying.
yeah.
Awesome. You actually try really hard. You have one of the harder jobs because if I don't cover every single science story that comes out every week, that's called normal. There's mammoth stacks of new research papers that come out every week. What nation is the bane of your existence when it comes to keeping track of rockets?
Keeping track.
Of
Uh,
what's going up and what has gone up?
China, because they don't say anything.
They just
Closely
spontaneously.
followed by SpaceX because they launched so much we can't say too much about everything that they do.
We have actually reached the point where you're pretty much just like using standard text, aren't you?
We were at that point for a while, and now we're doing also this week we're X number of Starlink launches.
Yes. Yes. Well, I sadly have so much more news. Now, we're going to read through the script, both
So we're
there.
doing more quality
So,
instead of saying the exact same thing about every single Starlink launch.
yes, exactly. Exactly. So right now, Eric and I are going to do a dry run through the script. We're actually going to do a higher quality recording tomorrow, when I can make sure that the lighting is right and Eric's lighting is right. And right now, I'm wearing the blue filtered glasses that don't belong on TV or anywhere else, but they're the ones we could find. Um, so you're going to get to hear all of this week's news. And then, if you subscribe to our podcast, if you subscribe to our YouTube channel, you will get a higher quality version. And if you want it before anyone else, become part of our Patreon at patreon.com/CosmoQuestX. So, do you have things pulled up on your end?
Yeah.
Okay. So I think we're just going to get started with things and we're going to pretend that there's commercial breaks that aren't actually going to exist. I feel like I kind of need Allie to kick in from the background during the commercial breaks with, if you'd like to see more content, donate now, or something ridiculous like
Sure,
that.
sure, I can do
I,
that.
Okay,
I've gotten
This is a
my
rare moment
recording
where I get to
mouse.
do the peanut gallery.
excellent. This was actually, you want to explain that comment to the audience who may not have been party to your, oh God, it's Eric's mouse again.
What? This isn't on. Hold on.
This is my recording mouse. I am using it.
Hello, hello, hello. Can everyone hear me?
Yes, yes, they
This
can.
is my
Okay,
gaming
wait, I
mouse. I'm
was
not
just
using it.
cracking jokes about actually getting to be the peanut gallery for once, which I don't normally get to do because of the way that we record this show. It's a little wild. Like, what Eric is in Minneapolis,
Yeah.
and I can't hear Eric. Let me get an earbud.
Okay.
But Eric's in Minneapolis, and Pamela is in Edwardsville, and I am in Philadelphia. I almost said Atlanta. Used to be in Atlanta. I'm in Philadelphia now. And so we are recording the show kind of asynchronous.
Yeah,
And usually I just let Pamela record herself because she keeps weird hours
it's
and
true.
usually gives me a better recording at some weird hour of the night. I always love looking at the timestamps on her files. And then Eric and I usually record rockets about the day before the episode goes out, so that we can be as up to date as possible on rocket launches. And so I just have a rare treat this time that I get to actually be in the room with Pamela. And we miss you, Eric. Wish you could be here. Maybe someday I will all three of us will get to be in a room. But yeah, that's EVSN is literally just the three of us.
Yeah.
And normally,
Weren't you there at the
What was that?
last
No.
Hangout-a-Thon a year ago? I could have sworn.
What's he saying?
Weren't you at the last? You weren't at the last hangout. You were at the July Hangout-a-Thon.
I was at the July Hangout-a-Thon. I wasn't at CosmoQuest-a-Con.
Yeah,
Oh.
you were at CosmoQuest-a-Con.
Couldn't fly out for that because, again, my other day job is at a boarding school wrangling teenagers. And that Hangout-a-Thon, I think, was during, it was around graduation.
Yeah, yeah.
Which is one of our busiest times. So I wasn't able to make it out for that. But yeah, it's as far as like the on-camera stuff and the editing, it is literally just the three of us. And
Producing a full-fledged television
Yes.
show, which is a bit obscene.
and thankfully we have help writing from Gordon, who's one of our community volunteers. He helps Eric with the rocket script, and Beth jumps in occasionally to help us do interviews when we have a scientist who's game to come play with us.
And if she knows that I wrote a script while not feeling well, she will proofread it and
Yes.
clean up whatever chaos came out of my keyboard. Our Instro, thank you so much for all the
Thank you for the
bits.
bits.
We are now up to 23232. It is a palindrome.
Yes.
I'm going to reload the other total.
Oh, wait, the number went up since the last time I looked at it.
It's hold on, why did it stop reloading? Okay. We are at $5,617.
That's like $500 more than the last time I looked at it. So that's exciting.
Yeah, we are
Thank you. Thank
we
you.
are making progress.
Yes.
It's kind of amazing.
So, as I was saying to Pamela earlier, I'm just feeling very like.
Come be on camera. We both fit here.
Okay. Hi. I'm just very excited that I actually I get to be the peanut gallery. I get to be here in one of the studios where this happens.
And inside of a gas giant.
yes.
If you pass slightly behind my chair, see, she's coming out of the gas giant. I'm kind of loving it.
Like, oh,
Somebody clip this.
you put me in front of a camera.
I did.
Yeah, this is what you get, and my just amazing hat hair. No pun intended. Yeah. So anyway, I'm gonna scoot back to my little table off screen and let Pamela actually record.
All right, so I'm going to go ahead and get started. There's no closer look because I have the hiccups. That's not the reason there's no closer look. Because we're going to start this week working to push our content out to to Reels on Insta and TikTok. And so we are, due to the fundraising totals, shortening EVSN to 30 minutes and taking the time to turn some of our smaller segments into Reels and TikToks to get science to more people. All right, so here we go. So if things look a little bit different this week, it's because I'm recording live from the set of Hangout-a-Thon 2023. Eric will be recording remotely because his schedule didn't allow travel this weekend. But for my segments, well, this year's Hangout-a-Thon is focused in on fundraising and trying to get the money we need to support this show and all the other shows we produce at CosmoQuest. And we are recording from my house, so it's hard for me not to be here. Over 32 hours across 3 days, we're recording interviews, playing games, spending time with some musical guests, and otherwise working to celebrate science as we record content you'll see during future episodes of EVSN. This is your reminder. We would do the show for the love of doing the show if we could. But because we have bills and we like to eat, sometimes too much due to stress, we ask that if you are able, please consider joining our Patreon community and making a one-time donation through our website. If you join our Patreon at patreon.com/CosmoQuestX for even $1 a month, you can get ad-free content, early access to videos, and bonus features. We just want to help you learn and do science and release accurate information under a Creative Commons license that lets it be played in schools and clubs without any copyright concerns. Okay, that's enough. I'm now going to focus on the science. This week we bring you news of Mars, quakes, fast radio bursts, and how merging stars make heavy atoms. We also look at stories from the launch pad with aerospace correspondent Eric Mattis. All this and more is coming to you right here on Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. One of the awesome things about growing older as an astronomer is you get to see the weird stuff no one understood in your youth become the everyday normal of your middle age. While we still don't understand things like dark matter or the accelerating expansion of our universe, I'm really enjoying the evolution of our understanding of gamma ray bursts. First discovered in the 1960s, the only things we knew for certain when I started astronomy, which was not in the 1960s, it was in the 1990s. Anyways, the only thing we knew at that point was bursts lasted several minutes in some cases, while others lasted a second or less. While that is information, it wasn't the most satisfying amount of information. Over the decades, we've come to learn that gamma ray bursts are triggered by at least 3 different phenomena, including the mergers of neutron stars. These wild events light up detectors of all kinds, with everything from gravitational waves to light from most colors all slamming into our world at once. These kinds of mergers have been theorized for a long time, but it was only in 2017 that one was finally observed, allowing researchers to confirm these mergers are the largest producers of heavy elements like gold. In March of this year, 2023, a 200-second-long gamma ray burst called attention to the merger of 2 neutron stars. As the massive yet tiny dead cores came together, they created a hot, high-density environment where atomic cores, neutrons, and fragmenting atoms could all slam together. This event was spotted by NASA's Fermi Gamma Ray Observatory, which, along with collaborations on the ground, measured its location with an accuracy sufficient to allow controllers to point the JWST at the explosion. In infrared light, they made out a distant pinprick of light called a kilonova in the outskirts of a spiral galaxy 120,000 light years away. Using a spectrometer, they were able to split the kilonova's light into a rainbow and look for the specific dips and peaks that indicate what elements are present. For the first time ever, they identified features associated with the atom tellurium. On Earth, this atom is more rare than platinum, and it's necessary in a number of manufacturing processes, including the tinting of glass and ceramics, as a catalyst for oil refining, and in the construction of solar cells. This means an ingredient in our planet's modern technology is born in the death of 2 stars. We are, after all, nothing more than star stuff. It's just wild what has to happen to create the diversity of atoms needed to create our wild world. Pairs of objects are responsible for some of the coolest phenomena in our universe, and while a lot of these pairs end up merging into a single object given enough time, there are a few, theoretically at least, that the universe carefully holds apart. In a new paper in Physical Review Letters, researchers led by Oscar Diaz explore the possibility that our universe can precisely balance the desire of gravity to pull black holes together against the ability of the universe's expansion to pull them apart. I was a physics teacher, physics professor, really, for many years. And I have to admit, if I was teaching graduate relativity, I'd have a new favorite homework assignment. Our reality is defined by the interaction of balanced and unbalanced forces. As I sit here, gravity pulls me into my chair, and the chair cushions and the structural integrity of my chair in the form of the normal force push up. The forces are balanced, and there's nothing to accelerate me into the air or drop me to the floor. Anytime you have multiple forces, you know it's possible if you work hard enough to figure out just how to balance things. In their models, they envisioned the simplest of systems, 2 non-spinning black holes. The physics doesn't care about their specific size. 2 non-spinning black holes, stellar mass is what they assumed. It just really cares that they're matched. They do look at the case of smaller black holes for a really good reason. They don't have, the smaller ones, the same associated physics as the larger ones. They just don't interact with their surroundings the same way. They find that it is possible to perfectly balance things across time and space, so the 2 systems will stay forever at the same separation. This isn't a forever kind of thing. Too much is constantly happening at the event horizon of black holes, and this balancing point just isn't stable. But for a time at least, 2 black holes can balance in space, maintaining a constant separation. And we will most likely see their lack of light and massive combined gravitational pull as coming from a single object. For all we know, we've already seen this kind of a balancing act, and we just didn't recognize it. But probably not. As I said, their work considered non-spinning black holes that are nicely identical. It is possible to expand this work out to include non-identical systems and spinning black holes, which should be the norm. But that's left for future work that I, for one, look forward to reading. To succeed in astronomy, you really need to either be really, really good with technology or really, really good with math. I personally am a technology person, and I'll happily operate telescopes and write software, but I'd really not do I'd really rather not do the seemingly endless juggling of variables and constants that goes into theoretical work. Luckily, there are actually folks out there with both the aptitude for maths and for computing. And it is one collaboration of these folks who have just brought us the new highest resolution model of our universe and its evolution over time. This work is described in 3 papers in monthly notices of the Royal Astronomical Society that address methods, the simulation's results, and a comparison of these results with our reality. This is one of the first models to consider cold dark matter, which is the primary component of our universe, and also the baryonic matter that we're made of, our tables are made of, everything that we're used to interacting with is made of. It also includes neutrinos, which honestly aren't exactly regular matter and also aren't cold dark matter. Past models left out regular matter because it is affected by the gas laws, and particles can build up into structures and otherwise interact in ways that are just a lot more complicated and computationally intensive. It was hoped that adding a richer diversity of materials would bring the models into closer correspondence with what we see in reality. And we'd be able to see in the models the physics driving the universe's expansion, or see where inconsistencies arise between what our models show and what reality does. Well, the simulation, called Flamingo, does better than past simulations at matching our universe. It still doesn't have the level of detail needed to know where our understanding goes wrong. It's a start, however, and the improvements being seen indicate that we're on the right track. It allows us to track how the temperatures of gas distribute, the distribution of dark matter, and the emission of X-ray light all track together, and how they affect the like of galactic winds and how those winds in turn play their own part. To do better, we're gonna need more powerful computers. I can only hope that with the constant advance of processor speeds, simulations like Flamingo will soon allow us to go, oh, that's where our equations are missing something, and figure out what factors are actually forcing apart our expanding universe. After a break, we're going to zoom in on our own corner of the universe and look at objects in our solar system, including brand new images from the Lucy mission of a little asteroid called Dinkinesh. Stay tuned.
Unmuting. This is the producer, and I'm being asked to beg for more money. We are doing this to raise funds to help keep the lights on at CosmoQuest, to help make sure that all the staff, and that includes me and Pamela and Eric and several other people you've met.
We're at $6,103.
Holy shit. Oh, sorry. Hi. For this and more colorful language, donate money. Thank you so much, everyone who has given money. Like, all of you are wonderful. And if you're not in a place where you can give money, which I totally get because this economy is bonkers,
Yeah.
to say the least, the best thing you can do is share our stuff. Just get it out there in the world. Go download our podcast, even if you're a Patreon subscriber who gets our ad-free podcast. Just go download it off whatever podcast platform you use.
Write reviews
because we do get a little bit of ad revenue through our podcast host, and your downloads help contribute to that. So that's one way that you can contribute to giving us money without having to spend your own if you're not in a place to give. And just there's so much you can do to help us. Yeah, I mean, Pamela was like, "You still have more time."
No. That was the wrap it up.
Oh, that was the wrap it up.
Yeah.
This is how tired I am. I should know that. I have worked in television long enough. I should know the wrap it up signal. Yes. So, yeah, I'm going to throw it back to Pamela for the next segment of EVSN.
All right. And this is a commercial to say that during the last hour of the show, we should be joined by musician, author, extraordinary human, Alex White. Alex, if you're out there watching, you're trying to join 2.5 hours early or 1.5 hours early. I no longer know how time works. Hopefully, Allie can drop you a text. All right. So, coming back from break. Back in October of 2021, a mission called Lucy lifted off on a multi-year journey to visit Jupiter's 2 collections of Trojan asteroids. Today, it is making its way through the asteroid belt before circling back to use the Earth to get a gravitational assist in 2024. While the asteroid belt is mostly empty space, researchers will go out of their way to match spacecraft trajectories with asteroid orbits to try and make sure no spacecraft passes through the belt without seeing at least 1 asteroid. Or maybe 2. On November 1st, Lucy flew past the asteroid Dinkinesh. Discovered in 1999, the system is about 0.7 kilometers across, just a bit bigger than Bennu. It was seen to vary in brightness, and it was assumed to just be rotational effects. As Lucy got closer and closer to the asteroid, however, researchers began to wonder if maybe, just maybe, they were actually seeing light from a second asteroid orbiting Dinkinesh in a moon or binary asteroid kind of a way. And in the November 1 image, we clearly see Dinkinesh has a friend. Estimated to be about 220 meters in size, this companion is still unnamed and represents one heck of a lucky find. In a quote that pleases my Gen X heart, principal investigator Hal Levison explains, quote, "When Lucy was originally selected for flight, we planned to fly by 7 asteroids. With the addition of Dinkinesh, 2 Trojan moons, and now this satellite, we've turned it up to 11. End quote. Once upon a time, we thought asteroids were just bland rocks. Turns out, if you actually look at them from up close, they are complex and interesting. With the Dawn mission, when the Dawn mission visited the largest asteroid series, it discovered ice volcanoes and geologically diverse landscapes and complex organic molecules. How the kind of chemistry necessary for life can end up on a beat-up, icy, inhospitable world is a bit of a mystery. And scientists are here to solve mysteries. Researchers at the Geological Society of America Connects meeting presented new research that compares the locations of organics on Ceres with the impact history of the world. Researchers used the NASA Ames vertical gun range, yes, they're shooting guns downward, to bombard simulated Ceres samples. These human-made compounds look like what we saw on Ceres and are letting researchers try things we just don't have the tech to try at Ceres. Specifically, they're shooting things at the artificial surface at speeds of 2 to 6 kilometers per second, with impact angles between 15 and 90 degrees. This is letting them test if small impactors, incoming micrometeors and their somewhat larger cousins, can break up the specific kinds of molecules seen at Ceres. They are then comparing what remains after impact with what is seen in different regions on Ceres. According to team researcher Tarek Dali, quote, Although researchers have performed impact and shock experiments on various types of organics in the past, what was missing was a study dedicated to the type of organics detected on Ceres, using the same type of analytical method used by the Dawn spacecraft to detect them. End quote. On Ceres, organics were found on older surfaces that also showed evidence of water. According to researcher Juan Rizos, quote, "We can see a very good correlation of organics with areas from older impacts and with other minerals like carbonates that also indicate the presence of water. While the origin of the organics remains poorly understood, we now have good evidence that they formed in Ceres and likely in the presence of water." End quote. We currently believe Ceres could have subsurface reservoirs of water. And now Rizos explains, quote, "There is a possibility that a large interior reservoir of organics may be found inside Ceres. So from my perspective, that result increases the astrobiological potential of Ceres." End quote. Now we just need to understand how hard or easy it is for organics to form into life. But that, again, is research for the future. And thank you so much for the bits. Every bit really counts. And I'm going to read. We are now up to $6,638.
Wow.
Literally before this segment, our producer Allie and I were brainstorming what needed cut. You're giving me hope, people. You're giving me hope.
We love you. We love you so much.
Okay, I'm going to keep bringing you science so that we can bring you rockets from Eric. All right, here we go. Here we go. Well, asteroids are proving themselves more complicated than we expected. Mars, in a fit of publications, is also demanding attention for all its icy complexity. Thank you so much, Renan G006. Thank you.
And Fenmel.
And Fenmel, yes. Back in May 2022, the InSight lander recorded a Mars quake with a magnitude of 4.7. While not all that large by Earth standards, this was the largest quake ever measured on Mars. This raised the question, was it caused by internal factors like tectonics? Or was it the result of a meteor impact that shook the world? So, a search was launched. Missions from the European Space Agency, the Chinese National Space Agency, the Indian Space Research Organization, and the United Arab Emirates Space Agency all combined efforts to search their data for a possible impact. According to a press release from the University of Oxford, quote, "This is thought to be the first time that all missions in orbit around Mars have collaborated on a single project." End quote. Thank you, our Instro. Thank you so much. Okay, so that collaboration, that first time ever collaboration of all the nations orbiting Mars, it found nothing. Nothing. And that is awesome. This null result, it implies that Mars still has a little bit of geologic activity ready to shake things up now and then. And those orbiting missions have plenty of science they can do when not searching for new impacts. For instance, data from the Mars Reconnaissance Orbiter 2001 Mars Odyssey and the now inactive Mars Global Surveyor have been combined by a collaboration led by Gareth Morgan and Than Putzig to produce detailed maps of subsurface water ice on Mars. From potential buried glaciers to ices trapped in crater floors, this team has puzzled out where water hides, waiting for future tech and potentially future humans to come and mine it to use in habitats and as fuel for spacecraft. But before we put more humans on Mars, we really need to understand exactly what life may lurk fossilized or alive, in the Martian landscape. In a paper led by Alexis Rodriguez, researchers map out the flow of water and work to find some place where local life could have pooled. And in Mars' northern lowlands, they found just what they wanted: the Hydrotes chaos region. According to Rodriguez, quote, initially biomolecules could have been dispersed throughout the volume of large groundwater-filled cavities. As the water was released to the surface and ponded, the water went away, leaving behind lags of sediments and potentially high concentrations of biomolecules, end quote. Collaborator Mary Beth Wilhelm adds, quote, NASA Ames is considering the plains as a possible landing site for a mission to search for evidence of biomarkers, specifically lipids. These biomolecules are extremely resistant and could have endured billions of years on Mars, end quote. A few episodes back, we covered how researchers have found ways to search for ancient lipids in sedimentary rock here on Earth. This future mission could take what we practiced here and extend it to Mars. Here's to hoping this is research that I'll see in my lifetime. As I said in the intro, we're recording this episode during our 32-hour Hangout-a-Thon. During a different hour, we're going to be interviewing some of the folks from the Mars Ice Paper, and that interview will be brought to you on our Patreon and on our YouTube channel. Up next, we have news on how cybersecurity... Actually, I cut that story. Up next, we have news on what's gone up, or at least tried to, from the launch pad with aerospace correspondent Eric Mattis. Stay tuned. Commercial break!
That's my cue. Hello, it's me again, your producer. And I see Eric just like, I don't know, Eric, you look like how I feel, just very, just zoned out.
Sorry.
No, don't apologize. I get it. And Eric's like, I'm waiting for my cue. I'm so sleep deprived. I've been running around, helping Pamela produce. We've been sharing producing duties all weekend. And I also got the bright idea to start doing NaNoWriMo during this event. So I'm a little loopy. I apologize. And once again, I'm back to beg for money. And for some reason, y'all think I'm funny enough to like throw a lot of money at, because our amount jumped up pretty fast there. So I once again super appreciate it. Super appreciate everyone who is giving and everyone who is sharing our lovely podcast everywhere. Just share the science. You know, we do these fundraisers so we can keep our podcast content free. And under Creative Commons, so that it can just be shared with everyone, because that's really like in our hearts, that's what we want to do. In a perfect world, we would be able to do all this for free, but you know, it's like I need to eat. So that we appreciate the money because it allows Pamela to pay us what we're worth. To pay us a fair living wage to do this work, to create this content for all of you, to just share the beauty and just wonder of science with the world. And we're so thankful that you make that happen. You make that happen by, you know, giving your spare change and by, again, like sharing our content. And, you know, if you're not in a position to give money, again, you can go download our podcast. And when you download our podcast, we get a little bit of money from the ads. We're sorry you have to listen to ads. You can always contribute to our Patreon to get ad-free versions. Because trust me, we're not thrilled about the ads, but you know, it helps. Every little bit helps. But again, the more money people give, the less we have to rely on things like ads. And that makes us happy.
All right. So I have tweeted out, I did not get to mastodoning out, but I have at least tweeted out where we are right now with the donations. We are at $6,666. We are at a palindrome.
Kind of a spooky palindrome.
I'm down. I'm down.
Yeah,
It's only a
yeah,
week
we like
after
it.
Halloween. Spooky numbers are our friend. Heart you. All right. We have more news. We're going to do more news. Okay, here we go with the more news. Next up, I'm pleased to welcome on aerospace correspondent Eric Mattis for this week's Tales from the Launchpad. Hey, Eric.
Hi, Pamela. Since the last show, there have been some human spaceflight activity, with another routine crew flight from China to their space station, and India completed a major milestone to their first crewed orbital flight. On October 21st, the Indian Space Research Organization launched the Gaganyaan abort test from the first launch pad at Satish Dhawan Space Center in southern India. Let's watch the launch.
That will be in the video.
We can show you the launch afterwards, maybe. The link's in the script. The launch was an in-flight abort test, which carried their in-development crew capsule to a specific altitude and speed to test part of its advanced three-part launch escape system. Testing of the system is very important to ensure crew safety during flight, and this is just the first of 4 in-flight abort tests that ISRO has planned. This first test used just the smaller high-altitude abort motor integrated into the fairing around the capsule, which is used if something happens during launch after the primary low-altitude abort motor has been jettisoned during the rocket's second stage burn. The first test of the system was the pad abort test back in 2018, using both of the motors at the same time. The other 3 in-flight tests, including this one, will demonstrate escape capabilities in other phases of flight. To accelerate the capsule to the required speed and altitude for the test, ISRO used a modified side booster from the GSLV Mark II rocket, fitted for... this is not being recorded, but I'm going to say the paragraph again.
Please do.
To accelerate the capsule to the required speed and altitude to the test, ISRO used a modified side booster from the GSLV Mark II rocket, fitted with an adapter for the much wider crew capsule. The first launch attempt on October 21st was scrubbed just after ignition due to an engine problem, but ISRO was able to resolve the problem and the launch took place about an hour later. The test was a complete success, with the capsule successfully splashing down 10 kilometers offshore under parachutes just a few minutes later, where it was fished out of the ocean by a waiting Indian Navy vessel. ISRO hopes to launch up to 3 uncrewed Gaganyaan spacecraft into orbit next year, followed by a crewed flight test in 2025. An Indian astronaut has also planned to fly on a NASA commercial crew mission in 2024. And 2 potential ISRO astronauts are currently being trained at NASA's Johnson Space Center for the mission. On October 26th, China launched a Long March 2F carrying the Shenzhou 17 crewed mission to the Tiangong space station. The crew of 3 included 2 first-time space travelers, along with the mission commander, who was previously part of Shenzhou 12. Let's watch the launch. 6.5 hours after launch, they successfully docked to the station. I can't scroll. Why can't I scroll?
I just like that you said that they docked the station instead of docking to the station. Can you scroll? You can use your gaming mouse. We understand.
No, it's not a issue of that. It's this is wide, and I've reached the bottom of the page. 6.5 hours after launch, they successfully docked to the station, joining the Shenzhou 16 crew who've been in space for 6 months. The new crew will do the usual research previous crews have, but also perform maintenance on the station's solar panels, a first for a Chinese crew. These have been damaged slightly by space debris in the time the station has been in orbit, but according to engineers, they are still functioning properly. A few days later, the Shenzhou 16 crew packed up some research samples and undocked from the station to return to Earth. They returned successfully, though observers noted a small hole in the spacecraft's parachute. The capsule landed safely, but it was pulled over in the wind by the parachute after landing, something that is not uncommon with Soyuz-style spacecraft. Fortunately, the taikonauts were unharmed by the experience and were extracted swiftly after landing. Also during this time were 6 Starlink launches, 3 classified Chinese launches, and 1 classified Russian launch. We keep track of orbital launches by launch site, also called spaceport, according to RocketLaunch.live. So far this year, the USA has had 88 launches, China 51, India 8, Kazakhstan and Russia each have had 7, New Zealand 6, French Guiana and Japan each have had 3, North Korea 2, and Iran, Israel, South Korea, and the United Kingdom each have had 1. Of these 179 launches, there have been 8 failures, reminding us that space is hard.
Thank you so much, Eric. Before we go, I'd like to share a bit of cooling news about our planet Earth. Beneath California's eastern Sierra Nevada mountains lies a massive, dormant supervolcano. 760,000 years ago, the Long Valley caldera formed with 650 cubic kilometers of ash getting thrown into the air in a rather terrible yet awesome eruption. Today, this region is seeing swarms of earthquakes, but they aren't actually a sign of volcanic activity. Instead, as the magma chamber beneath the caldera cools, it is releasing fluids and gases that cause tremors. This work is described in a new paper in Science Advances led by Zhongwen Zhan. According to Zhan, quote, we don't think the region is gearing up for another supervolcanic eruption, but the cooling process may release enough gas and liquid to cause earthquakes and small eruptions. For example, in May 1980, there were 4 magnitude 6 earthquakes in that region alone. End quote. It's good to know that at least one of Earth's hotspots is cooling. This is your reminder. Naples and Yellowstone supervolcanoes may yet one day roar back to life. But that's it for today. Good night, everyone, and remember to go out and look up. All right, that ends our recording of the episode. We're still sitting at $6,666. This puts us $3,334 away from where we really need to get to not have to make the cuts Allie and I were talking about before this segment. Here's to hoping, here's to dreaming. But in the interim, here is to Minecrafting. Whose stream am I going to?
I don't know. Is Veronica ready?
Veronica, you ready? I am currently not sending information to Veronica. Veronica, are you ready? I have a subtle nod yes. All right, we are going to transition over to Minecraft. Veronica, take it away.
Helps if I unmute. There's anything we've learned this weekend, it always helps to unmute. All right. Okay, so we are going to take a look at some of the recent discoveries here on Mars. As you can see, we have quite the complex going here. But recently, some exploration was done a little bit further afield, and we found a few anomalies. So first off, in this direction, it was noted that there is a alternate site. Apparently, this is standard procedure because you don't want to, have everything land in the same place. So And interesting enough, these colors, this is considered a bullseye here because the standard orange or red and white wouldn't stand out as much on Mars. So green was used as the alternate bright color that you can't miss. And then here on the hill, this looks to be an alternate radio uh, facility. This doesn't seem to have any equipment in it currently, but it's good to know that we have a backup just in case. And when that was discovered, on the way back, we noticed that there had been a supply drop. It didn't quite make the landing zone, but it was wrapped up in plenty of, I don't want to say bubble wrap, but it has a nice soft outer core. So we're going to take a quick look inside and see what we got delivered. Oh, looks like it's already been. Wonder who else has been taking stuff out. Okay. Oh, good. We got some more food. Got some chicken, and oh, empty containers for more samples. Woohoo! We got plenty of samples. So as you fly over to take a look at all the buildings, I want to point out all the different types of um, radiation. Uh, words. Words are hard. Radiation shielding that have been used. We have water, terracotta, cement, and then this is just using Mars Earth or red sand if you're a Minecraft. But this has a lot of, this one has actually double layers of protection because we don't want to mess up any of our samples. I think the intention was for this to be a clean room, but that grit just kind of gets everywhere. We try and take the suits off so we don't cross-contaminate, but you know how it goes. And I believe this was, yeah, this was, everything that you're seeing here is built by our community members. We've got our satellite dish, a beautiful flower garden, a library, a place to grow produce, so we got food to eat, Ingenuity 2, a rover, uh, the lander, and the crane so that we can build more buildings. The first greenhouse, this is kind of the first general building. We've got this crawler explorer type rover here, but this one has places for us to sit so you can drive it. And let's see, my computer's kind of freezing for a second. So hopefully it's not freezing for y'all, but uh, it is on my end. I am having technical. Kind of. All right. So, and off in the distance, that white building you see there, that I believe was also built by, was it not the Brain? And then on the other side of that is the well, because they did find ice under the surface of Mars. Now, there was more I planned on showing you, but since Minecraft has decided to stop responding, let's see what else we can see from here. Okay. Well, not seeing any improvement. I do love the parachute that is still there. I know I've heard lots of stories about people making clothing and things out of parachutes. I wonder what happened to the rest of it, though. I'll take a quick look in chat. Thanks for all you do. Yeah, I see it in the software. Thank you. Excellent. So we're stuck at a palindrome, and I'm hoping that we can get a little bit more because we still have money to raise. So if you have the ability, please donate if you can, and if you can't, please share out, download podcasts. Oh, some parachutes have a message, and right, which I can't remember the name. I don't remember which one it was, but I remember it was orange and white, and people worked out the code, and then some clever clothing company made a skirt with the same patterns in it. Yeah. So, oh, Fan, we're just looking things up. So, Valley, Yellowstone. Oh, okay. Yeah. Yeah. One time we talked about doing a trip with the CosmoQuest crew to Yellowstone. I still think that would be an awesome place, and especially if we can do it at the right time so that Pamela doesn't bring more clouds. That would be wonderful. Oh, Pamela, wear the same shirt. Good observation, Fenwell. Thank you. All right, well, let's go back to the crew and see what's going on for the next hour.
All right, this is Pamela coming in as the voice not on camera. I think I have to go find my Dare Mighty Things shirt. So I'm going to hand the mic over to Allie, and then I will be back on set in just a moment.
Hello, everyone. Are we live? We're live. Oh, we're live. Cool.
No,
Did you
I
hit-
forgot the YouTube thing.
This is why we are exploring other production software where we only have to hit one go live button, and that's not